let me be clear with the units first. There you go. Okay, remember that this is C is equal to your charge divided by your potential. Okay, now C is farad. So farad is equal to coulombs, because it's Q, coulombs divided by your volts. So C over V is F, okay, coulomb over volt. What else? Yeah, from Q over V, we knew before that my E, if I've got a surface charge density, it will be my sigma divided by my epsilon naught. If you do remember that, I do hope so, okay? Now, your sigma divided by epsilon naught can also be equal to, you think of something else? What do you remember when you're talking about surface charge density? This is actually Q divided by area. So if that is Q divided by area, we can further simplify this or use our E to equate to that one. So that would be Q divided by your area divided by epsilon naught. So that is 1 times 1 over epsilon naught. That is epsilon naught over there. Okay, so if you're given E and you've got your charge and area, just use that one, right? We also remember before that your V is equal to ED. I hope you remember that. Okay, V is equal to ED. Now, if you know that E looks like that and just multiply it, that will be, remember the Q divided by A. So that is Q divided by A times 1 over epsilon naught. That is your E times your D. And simplifying it, that would look like QD divided by A epsilon naught. That is your V. Okay, from your V, I can use that to have another equation here. Yeah, so that is C is equal to Q divided by, this is it, QD divided by A epsilon naught. Simplifying, I would get, yes, I will cancel my Q. What else? I'll get epsilon naught here, A epsilon naught divided by D. Okay, you're switching positions in this case. A epsilon naught divided by D. This is class the capacitance of a parallel plate capacitor. You don't need this kind of derivation, but please remember that this is your C of a parallel plate capacitor. No, given. So that is D is equal to 1 cm. Your C is 2.5 micro. Okay. Required area. Area of C. Equation. What's your equation? Yeah. To get that. What do you remember? Has to do with area. It has to do with area. What is it? Look at this. Can I use my C is equal to Q over V? No. This is a parallel plate capacitor, so I'm going to be using the final one. A epsilon naught over D. Okay. Let's try it. A epsilon naught over D. C is equal to A epsilon naught over D. Solution. What's your solution? We need the A. So from this, manipulate, I can get C, D is equal to A epsilon naught divided by epsilon naught square meter. There you go. Okay. All right. That is your area of the capacitor. Next one. Given its area equals 2.00 square meter, V is 10.0 kV, D is 5.00 mm. Required is a capacitance, letter A, capacitance, letter B, the charge on each plate, so QA, and then QB, okay? And let us see the magnitude of your electric field. So what is E? Okay? Equation. Let's have equation for letter A. Letter A. Okay, what is our equation for letter A? C is equal to area epsilon naught over D. All right, do we have area? We do. That's 2. Do we have epsilon naught? Of course we do. That's 8.85 times 8. That's 8 times 10 raised to negative 12 divided by your distance. Do we have distance? It's 5 mm, okay? Convert it. Times 10 raised to negative 3. Good. Negative 3. Okay, answer? 3.54 to negative 9. Negative 9 is? What is negative 9? Nano, micro. Nano. Okay, so that is 3.54 nanofarad. That's letter A. What about letter B? Wait, let me put solution here. For letter A, this is it. There you go. Right. For letter B, letter B what? We need Q, so that would be CV is equal to Q. Okay, so what's my C? What's my V? C is 3.54 nano. So 3.54 times 10 raised to negative 9. What's my V? In this case is 10 kilo. Is that 0.0? 10 kilo. Kilo is? 3 point? Yes, okay. That's 3.54 times 10 raised to negative 5. I didn't put the units, just so you know, it's the charge we're looking for, so it's in coulombs. Coulombs. Okay. Okay, what about letter C? C. We're looking for the magnitude of the electric field. E is equal to Q epsilon naught, right? Okay. Let's plug in the values. What is our Q? 3.54 times 10 raised to negative 5 coulombs divided by your area, which is 2. Epsilon naught is 8.85, negative 12. Answer? Okay, so that is 2.00. I've got 3 sig figs here, times 10 raised to 6. It's electric field. So what do I expect based on our previous discussions? It's N over C, newtons per coulomb. N over C. Of course, you can make use of the units individually and then know them, like, oh, should I be canceling? But you can. That's a very good one. But practically, it's not really great because it's an exam, okay, with positive charges. Okay, so you have 3 divisions. All right, from the center to your Gaussian surface, that's your radius. So in words, imagine there are 2 spherical conducting shells, okay, separated by a vacuum. Now this is our vacuum, separated by a vacuum. The inner shell, because we've got to, the inner shell has positive Q and the outer shell has negative Q. You have to find the capacitance of this spherical capacitor. You're looking for the capacitance of the spherical capacitor. Do I have a Q? What about a V? Maybe I can make use of another equation. Can I? Do I have area? No. Do I have distance? I don't have that either. I only know that one is radius A and one is radius B. So, these are units, okay? Don't think this is force. Units. Units. Yeah. How else can I get my C? That's your V, okay? But if we're looking for the potential difference, there must be VA and then VB. Correct? Yes. So this V is actually AB. We're looking for that, okay? Look for V first. VAB first. How do we get that? Okay, so VAB is equal to, okay, after which, just plug it in. Plug it in. That would be your C is equal to Q divided by Q over 4 pi epsilon naught RB minus RA divided by RARB. So, what's the answer here? You're going to be cancelling out your Q. We're looking for the capacitance. Okay, so for example, it is given that your RA, let's say RA, let me think, let's say 5. Okay, imagine your RA is 5 cm and RB is 7.5 cm, maybe. What's your capacitance? Then you have to get the capacitance using the formula that we just got, this one. 4 pi epsilon naught. Okay. What is the capacitance in this case? Divided by RB minus RA. Okay. Answer. Let's calculate. 4 pi times 8.85 negative 12. Okay. RARB. So that's 5 times. You've got, it has to be in cm. Gotta convert it. M. So 5 times 10 negative 2. 7.5 times 10 negative 2. M. Okay. And that's it. That's for a spherical capacitor.